In the vast, silent theater of space, countless objects are in constant motion. Some are on a journey that will eventually intersect with our own, while the idea of a single giant meteor on an imminent collision course with Earth captures our imagination and our deepest fears. The reality is both more common and far more complex than you might think. The story of these celestial visitors is written across our planet's 4.5 billion-year history and continues to unfold quietly and dramatically and every single day. To truly understand the risks and wonders that lie ahead, we must first look to the sky and to the ancient silent travelers that wander through it. This is the story of the rocks that fall from space. To begin our journey, we must first clarify our terms, because the language of the cosmos has a specific and beautiful precision. What we often call a meteor is actually just one stage of a three-part process. It all starts far from Earth, typically in the asteroid belt, a sprawling ring of rock and metal orbiting the Sun between Mars and Jupiter. Here we find asteroids ranging from pebble-sized rocks to dwarf planets hundreds of miles in diameter. When these bodies collide, they can shatter, sending smaller fragments adrift. These pieces, broken off from asteroids or shed by passing comets, are called meteoroids. They can be as small as a grain of sand or as large as a city block, and for millions of years drifting silently through the solar system. But when a meteoroid's orbit crosses Earth's path, it is captured by our planet's gravity. It begins a final, fiery plunge. As it plummets into our atmosphere at incredible speeds, often exceeding 70,000 miles per hour, the immense pressure and friction with the air molecules cause it to heat up and glow intensely. This brilliant, fleeting streak of light is the meteor, what we have poetically called a shooting star for millennia. Most of these visitors are small and vaporize completely, harmlessly painting the night sky in a momentary display of space art. But if a meteoroid is large and dense enough to survive this violent descent and strike the ground, it earns its final name, a meteorite. A tangible piece of another world, a messenger from the void, delivered right to our doorstep. These deliveries, however, are not always gentle. 66 million years ago, a visitor of almost unimaginable scale arrived. An asteroid, estimated to be at least 6 miles wide, slammed into the shallow ocean near what is now the Yucatan Peninsula in Mexico. The impact, known as the Chicxulub event, was cataclysmic. It released energy equivalent to billions of atomic bombs, gouging a crater over 100 miles wide and dozens of miles deep. The initial blast would have vaporized everything for hundreds of miles, triggering mega tsunamis that washed across continents and earthquakes that shook the entire planet. It sent a plume of superheated rock, dust, and sulfur into the atmosphere, shrouding the globe in darkness. Sunlight was blocked for years, causing global temperatures to plummet in a devastating impact winter. Photosynthesis ceased, plants died, and the entire food chain collapsed. This single event triggered a mass extinction that wiped out nearly 75% of all species on Earth, including, most famously, the non-avian dinosaurs. It was a planetary reset button, a stark and humbling reminder that the sky above is not just a ceiling, but an ocean of cosmic potential and peril. While an impact of that magnitude is exceedingly rare, smaller but still potent events have occurred within recorded human history. In 1908, in a remote, sparsely populated region of Siberia near the Podkamenia-Tunguska River, a colossal explosion occurred. It flattened over 800 square miles of taiga forest, an area larger than modern-day London, felling an estimated 80 million trees in a radial pattern. Eyewitnesses, some hundreds of miles away, reported seeing a column of blue light, nearly as bright as the sun, moving across the sky. It was followed by a sound like artillery fire and a powerful shockwave that knocked people off their feet and shattered windows in distant settlement. Yet, for all this devastation, no impact crater was ever found. The leading scientific theory is that a stony asteroid or a piece of a comet, perhaps 200 feet in diameter, entered the atmosphere and exploded in a massive airburst several miles above the ground. The sheer force of the atmospheric blast was enough to cause all the destruction on the surface. The Tunguska event remains a chilling example of the power these objects possess, even without striking the Earth. More recently, in February of 2013, the world witnessed a similar event in stunning real-time detail. A previously undetected asteroid about 65 feet wide entered the atmosphere over the Russian city of Chelyabinsk. It became a superbolide, a meteor that for a moment shone brighter than the sun and was captured on countless dashcams, security cameras, and cell phones. It too exploded in a powerful airburst miles above the ground. The resulting shockwave, arriving a few minutes after the flash, blew out windows in thousands of buildings across the region. Over 1,500 people were injured, not by the meteor itself, but by shards of flying glass. The Chelyabinsk event was a global wake-up call. It starkly demonstrated that even relatively small objects, far too small to be tracked by most long-range astronomical surveys, can enter our atmosphere without warning and pose a significant regional threat. So how do we protect ourselves from a future threat? This is the critical mission of planetary defense. Today, agencies like NASA and the European Space Agency operate a global network of sophisticated ground-based and space telescopes. They constantly scan the heavens for near-Earth objects, or NEOs, asteroids and comets whose orbits bring them into our cosmic neighborhood. Scientists meticulously track their paths, calculate their trajectories with incredible precision, and assess any potential risk of impact decades or even centuries in advance. For a long time, the question of what we could actually do if we found one on a collision course was purely hypothetical. But in 2022, we got a spectacular answer. NASA's Double Asteroid Redirection Test, or DART mission, successfully demonstrated a technique known as the kinetic impactor. A refrigerator-sized spacecraft was deliberately crashed into a small asteroid named Dimorphos, millions of miles from Earth. The goal wasn't to destroy it, but to give it a small nudge, to change its speed and alter its orbit ever so slightly. The mission was a resounding success, proving that humanity now possesses a viable, tested method for deflecting a hazardous asteroid, provided we have enough warning time. It was a monumental achievement, transforming us from passive observers of cosmic fate into active guardians of our own planet. Every single day, about 100 tons of interplanetary material falls onto Earth, most of it as harmless, microscopic dust that settles unnoticed. The sky is not falling, but it is constantly delivering messages from the past, from the very formation of our solar system. The flashes of light we wish upon are the final moments of ancient travelers. The meteorites we find preserved in our deserts and ice fields are physical relics of distant worlds, offering clues to the birth of planets. And the great impact events of the past are cautionary tales written into our planet's very geology. They remind us of our vulnerability in a dynamic cosmos, but also of the incredible resilience of life and the power of human ingenuity. So we continue to watch the sky, not with constant fear, but with profound curiosity, with deep respect, and with the knowledge that our quiet blue marble is part of a much larger, more intricate and endlessly fascinating cosmic dance.